All right, this video is on how to solve rational equations. So I'm just going to go ahead and get started with one that's really simple, so you can see kind of the common sense or the intuition behind how it works, and then we're going to get into ones that are, a little bit more difficult. So the first example is if I have 1/7 plus x over 7, and it equals 5/7, then what does x equal? So if you have 1/7 plus something sevenths equals 5/7, then obviously x is going to equal 4/7. So the way that we're going to do these problems is we're going to say, well, if you have little rational expressions, a rational expression, a rational expression, a rational expression, if you can have this rational equation written so that you have a common denominator, which is what we have here, that's why we're able to solve this intuitively. That's why we can say, oh, 1 plus something equals 5, and then say, oh, that something must be 4. It's because we get to ignore the sevens. We say, oh, we have that common denominator, so really what I'm solving in my head is I'm saying, oh, 1 plus x equals 5, and then I can go ahead and subtract the 1 and say, oh, x equals 4. The fact that they're all sevens is what made that problem, easy for me to solve. So we're going to use that idea to do all of these problems. We're going to say, first, I'm going to get a common denominator between each of my rational expressions. Then I'm going to ditch that denominator and just solve the equation like I would any normal equation. All right, so here's our first problem. I'm going to have 1 plus 1 over r minus 1 equals 4 over r minus 1. All right, so first things first, I need to get a common denominator so that I can ditch it. Easy enough. Okay, so I have rational expression, rational expression. This right here is not a rational expression, that's a whole number. So I'm going to go ahead and write that as a fraction to start with. I'm going to put it over 1. Okay, so between all three of these terms, I can see, all right, that common denominator that I'm going to get is going to be r minus 1, which means that if I want that first fraction to have the common denominator with the rest of them, I'm going to multiply it by r minus 1 on the top and r minus 1 on the bottom. All right, so the equation that I have now is r minus 1 over r minus 1 plus 1 over r minus 1 equals 4 over r minus 1. And now I can do exactly what I did here, where I was like, okay, mentally ditch the sevens, 1 plus x equals 5. I'm going to ditch the r minus 1s. So I have the equation r minus 1 plus 1 equals 4. Minus 1 plus 1, well, those cancel. We just get r equals 4. There's our answer. Okay. Now we have to add one more layer to it because this is a rational expression and we do have something that we learned about previously, and that was excluded values. So we always have to go back and check our answer and make sure that it's not a value that should have been excluded based on the denominators in the original problem. So if we go back to the original problem, we're going to say, okay, looking at our denominator, and you can do it based on the common denominator too, actually. Looking at the denominator, we have r minus 1. That means that our excluded value for this problem is r cannot equal positive 1. Because this denominator is one of those that would have been in parentheses. And for the parentheses denominators, we do opposite sign, and the opposite sign is positive 1. Now, as long as this answer is not the same as the answer you got, you're fine. So 4 is a fine answer. I can have anything except for 1. 4 is not 1. I'm good to go. Okay? Most of the time, you're going to be fine. Most of the time, your answer is going to be okay. Every so often, your answer might be the same as the excluded value. And if that is the case, you'd be like, oh, well, there's no solution to this problem. I can't solve it. Okay? All right, I'm going to repeat that again once we get to the next problem because I know that is kind of the funky part of these problems. The rest of them might seem a little bit more normal. The excluded value, I know, makes students a little bit uncomfortable. Okay? So I just want to say I got the excluded value from here. I compare it with my answer, and then I go, yep, I'm good. All right, let's do another example. The problem is 4n plus 24 over n plus n minus 4 over 2n equals 1 over 2. All right, so here is the problem. Again, we're going to start off getting that common denominator, okay? So between all three of these fractions, the common denominator that we need is going to be 2n. You can see I've got a 2, I've got a 2, I've got an n, I've got an n. So the common denominator between all three of these is 2n, okay? So the first fraction is going to need a 2 on the top and the bottom. The second fraction has the 2n, we don't need anything there. The third fraction is going to need an n on the top and the bottom. All right, so we've got the 2n, the 2n, the 2n. Okay, I'm going to go ahead and write down everything we have. So I'll distribute that too. We have 8n plus 48 over 2n. We have n minus 4 over 2n. We have n over 2n. Okay, I've written it all out. Now, if you guys recall from when we did excluded values, anytime we have a monomial in the denominator, so this is a monomial, it doesn't have parentheses, it doesn't have two terms, it's one term, that means the excluded value is 0, n cannot equal 0. Okay, so I got the excluded value from that. All right, I'm going to go ahead and get rid of my denominator so I can make my equation. So I'm ditching my denominator. So the equation that I'm solving is 8n plus 48 plus n minus 4 equals n. So 8n plus n is 9n. 48 minus 4 is 44 equals n. I'm going to go ahead and get my n's to the same side by subtracting 8. Subtracting 9n, I'm doing math in my head. Yes, 9n. 44 equals negative 8. That's where the 8 came from. All right, negative 8n. And then I'll go ahead to get the n alone. I'll go ahead and divide by negative 8. 44 over 8, both of those are divisible by 4. So I have the top divided by 4 is 11, the bottom divided by 4 is 2, so I have negative 11 halves is what n equals. Now, I knew my answer was okay as long as my answer wasn't 0. My answer is not 0, so my answer is good. It's a good answer. Didn't have to worry about it. All right. Let's do another example problem. All right, we got m minus 1 over 3m squared minus m minus 1 over 6m squared minus 2m equals m squared minus m minus 12 over 12m squared minus 4m. So all of these denominators are binomial, binomial, binomial. I am not going to assume that my common denominator is multiplying all three of these together. I'm going to factor each one of these because I'm assuming they probably have something in common. So between 3m squared and m, the GCF is m. And then when I factor that m out, I get 3m minus 1. That's probably what's in common. Okay, between these two, I have a 2 in common and an m. Okay, and then a 3m minus 1. Yep, that's what we're getting. And then over here, between the 12 and the 4, I've got a 4n common and an m, okay, and then a 3m minus 1. Yep, called it. Okay, so our common denominator, we need an m for all of these. We got the 4, we got the 2, so it looks like we need 4 in the front. So we need 4 in the front, we need an m in the front, we need a 3m minus 1. That's what we need for our common denominator. Okay, so this fraction has it. This fraction doesn't need anything, it has the entire common denominator. This fraction has a 2 in the front, so it needs another 2 in the front so that it can be 4, right? So we need to multiply by 2 on the bottom, we need to multiply by 2 on the top. Okay, this fraction just has an m in the front, it needs a 4. So we're going to multiply by 4 on the top, we're going to multiply by 4 on the bottom. I should have put that in parentheses. Okay. All right, so let's go ahead and we're going to write down what we have here. So I'm going to distribute the 4. 4m minus 4. Over that denominator, I'm going to write the factored version. I guess it doesn't matter because we're about to ditch it anyway. 2 times 1 is 2. 4m, 3m minus 1. And then this is the one we didn't have to do anything to. Okay. All right. So I'm going to go ahead and write down my 2 excluded values on the next page, and I'm going to go ahead and write down, since I'm at the bottom of my notes page here, I'm going to go ahead and write down my equation. So this is the point where I can kind of ditch that denominator anyway. So the equation that I have is 4m minus 4 minus 2 equals m squared minus m minus 12. Okay, so our common denominator has 2 excluded values. This first one is an excluded value like a monomial, so this would be m cannot equal 0. This is an excluded value like parentheses, so it's the opposite sign, and it would be positive 1/3. Positive 1/3. So those are the 2 excluded values. I'm going to go ahead and do the problem. As long as I don't get one of those values, my answer is fine. Okay, so I have 4m minus 6 equals m squared minus m minus 12. I can tell very clearly that this is a trinomial. I'm going to have to factor to solve this. This has to equal 0 when I factor to solve this. So I need to go ahead and make this equal 0 before I start factoring. So 0 equals m squared minus 5m minus 6. So I'm looking for 2 numbers that multiply to negative 6 but add to negative 5. So that would be negative 6 and 1. Yep. Okay, so factors are m minus 6, m plus 1. So that means that our solutions are positive 6 and negative 1. And those solutions are both good because those solutions are not 0 and 1/3. So as long as they are not the excluded values, those solutions are fine.